Deployment of offshore wind energy will be critical to our clean energy transition, but some of the biggest challenges involves the supply chain logistics of moving the wind turbine blades. And a lot of that stems from the materials and processes that were adapted from boat making almost 60 years ago. And so our company develops new manufacturing processes for wind turbine blades that allows us to automate the process, miniaturize the process, and mobilize it so we can do it as close to the turbines as possible.
We use a laser to heat up the material, and with a high-resolution camera, we monitor the thermal expansion, and we're able to measure 4 important properties. And think of it as this intelligent microscope, essentially. So yes, we can measure material properties like fiber orientation and reinforced composites, coefficient of thermal expansion, or CTE, it's a fundamental property in the design phase, defect detection, such as micro-cracking, and also residual stress monitoring.
So currently in the USA, around 70% of waste is considered as an unrecyclable or hard to recycle. So in our company, we have a groundbreaking technology that we can breaking down of this unrecyclable mixed plastic into valuable chemicals.
Over half of the building stocks that were built before the 2009 energy codes were implemented were not designed for energy efficiency. And property managers of some of these building stocks are struggling to find code-compliant retrofits that offer a balance between sensible year-round heating and cooling and adequate or easy to install insulation. It's applied at the surface level of the walls, and what it would do, it would remediate the inefficiency of the wall, as well as provide heating, cooling, and thermal insulation.
I worked at several different manufacturing companies, one of which was in an area called lost foam casting, which is kind of a niche type of investment casting. And that is like the greenest metal manufacturing process, but it has really high tooling costs. So we started trying to work to figure out a way we could use 3D printing to eliminate the tooling cost. But it also has more broader applications beyond just the lost foam industry itself.
We are solving the big problem of energy storage. The way it goes is when sun is not shining and wind is not blowing, how do you power your homes or factory floor? You can only do that if you have stored energy when sun was shining or wind was blowing. Now, we look at this problem slightly differently from the lens of our customers. The problem is with more and more solar and wind going online in the grid, the durations of energy storage that are going to be required will change. Today, the customers are asking for 4 to 6 to 8 hours of energy storage duration, and it will move on to several tens of hours in the future. So what we are bringing is a flexible energy storage solution that can do smaller duration, 4 to 6 hours today, and can continue to solve the problem of longer durations of energy storage in the future for our customers.
We are developing optimization technology for different engineering problems. And currently our first use case, our first quantum solution, our first solution is optimizing the design of wind farms, finding optimal placements of turbines for wind farms.